In this problem, we have two Hermitian operators, A and B. We need to prove that I multiplied to the commutator operator, A comma B, is Hermitian. Before proceeding, let me note down a few things. We have, let's say, two eigenfunctions, psi m and psi n. Now it's mentioned that our operators A and B are Hermitian. So that means we have the integral negative infinity to positive infinity psi star m times we have the operator A operating on psi n dx. That's the same thing as applying the operator A on psi m, and then we take the conjugate times psi n dx. The same goes for operator B as well. Now we have here I times the operator AB. So this is the commutator operator. So this is simply AB minus BA. So what we have to do, we have to show that this particular operator is Hermitian. All we need to show is that if we take the integral from negative infinity to positive infinity, then psi star m times we have this operator. When it operates on psi n dx, this must be equals to the integral going from negative infinity to positive infinity. So we have I times the operator A comma B operating on psi m. Then we take the conjugate of the result and then multiply it with psi n dx. If this relationship holds, then we say that our given operator is Hermitian. So we'll begin from the left hand side. So on the left hand side we have integral with the limits going from negative infinity to positive infinity psi star m. We have I times the commutator operator A comma B psi n dx. Now we're going to expand this. So this will be the integral negative infinity to positive infinity. We have psi star m I times AB minus BA, and it operates on the eigenfunction psi n dx. Now we can expand this integral. So we have I, which is just a number. So that will be multiplied to integral going from negative infinity to positive infinity. So we have psi star m times the operator AB operating on the eigenfunction psi n dx minus I times the integral going from negative infinity to positive infinity psi star m. Then we have BA operating on psi n dx. Now we will use the definition of the Hermitian operator. Here we see that the operator A, this is operating on B psi n. So that means we can rewrite it as I times the integral going from negative infinity to positive infinity. So here we have A star, so this operates on psi star m times B psi n dx minus I times integral going from negative infinity to positive infinity. So here also we see that the operator B operates on A psi n. So that means we have the conjugate of the operator B operates on psi star m multiplied to A psi n dx. Then we again have the operator B operating on psi n. So that means since B is Hermitian, so we have I times integral going from negative infinity to positive infinity. We have B conjugate, which operates on A conjugate operating on psi star n. So this is m times psi n dx. minus I times integral going from negative infinity to positive infinity. So here we have the operator A operating on psi n. So this will be simply the conjugate of operator A operating on B star psi star m multiplied to psi n dx. Now we're going to combine this two integral, but we're going to take negative I as the common factor. So we have negative I multiplied to the integral going from negative infinity to positive infinity. So consider the second integral. So we have A conjugate B conjugate psi star m minus the first integral. So that will be B star A star psi star m whole multiplied to psi n dx, which will be negative I times integral going from negative infinity to positive infinity. So this two terms can be also written as A star B star minus B star A star operating on psi star m times psi n dx. Now if we take the negative I inside, since I is simply a number, then we will have the integral going from negative infinity to positive infinity. So negative I, we'll just write it as I times, we have A B minus B A, then we take the conjugate of this entire thing. So conjugate of I is simply negative I, but that is how we have absorbed negative I inside. This operates on psi star m all multiplied to psi n dx, and this will be simply I. So this is the commutator operator. So this is A comma B. So this is operating on psi m, and we take the conjugate times psi n dx. So this means that let me write it down. So here we started out with the integral negative infinity to positive infinity psi star m. We had I and times the commutator operator A comma B operating on psi n dx, and we obtain this particular integral, which proves that operator I times the commutator operator A comma B is Hermitian. This is what we are asked to prove. Thank you.